Okay, hello everyone. Vincent Sirasol again, getting started with our third and final, the concluding session on organic gardening. And just for new people, I've been a commercial organic gardener for 13 years. Served on the board of directors of the New York State Organic Gardening Association for 7 years. And retired and moved to New Hampshire, and now I've spent my time writing a book on organic gardening. It's called How to Grow a Vegetable Garden That Cannot Fail. The book is for sale here at the library if anyone is interested in buying it. And as I said, retired, left Long Island, New York, moved to New Hampshire, and now I write books and I teach gardening courses.
And the second volume of the book, somebody asked about?
The second volume of the book is almost ready, but not quite, and I need at least another month to get it out to the world. I know my timing is off, but I'm doing the best I can. Okay, so tonight we're going to see another video. We're getting very happy comments on the impact of the video, and tonight's is going to be another one. You're going to be absolutely astounded at what you see in tonight's video. I'm very happy and proud to show these things because they transmit educational information a million times more effectively than I can. And combining them with lecture works out real well. I just want to start tonight by quickly going through some of the things that we've already touched on. We've already gone into in detail. Tonight I just want to touch them as a brief overview and review and refresher for everyone. Started with we started the first session, what is soil, and we made a distinction. Soil is not what we call dirt. Soil is a mixture of some non-living components like sand, silt, and clay, and then air, water, and minerals seep their way into the spaces between the granules. And then there's humus, peat moss, manures, leaves and twigs in the soil. And then there are living organisms in the soil. We all seen worms and we've seen bugs, and there is a whole plethora of living creatures that we cannot see because they're microscopic. They're so tiny, they're microscopic, but they consist of bacteria and fungi, some parasites, some nematodes, protozoa, etc., different microscopic life forms, which really make the whole plant growing possible. These microbes are the basic plant feeders and plant supporters. And we went into details on specifically how that works. The essence of organic gardening is building and maintaining soil. Build the soil and let the soil organisms feed your plants. And that's the organic system. So we use amendments and practices, procedures that encourage, that give the creatures we want to live in the soil, that gives them what they need to support their life. There are a few of the procedures that we use, multi-cropping, plant many different plants, don't just plant a tomato garden. Crop rotation, don't plant the same plants the same place year after year. Cover cropping, after you clean up your garden at the end of the season, your vegetable plants have been sucking nutrients out of the soil all season long. And in the winter, you have an opportunity to re-establish nutrients in the soil And the way you do that is to plant what we call a cover crop. A cover crop consists of grasses. I don't mean the kind of grass you have in your lawn. I mean giant grasses that grow 2, 3, 4 feet high. Buckwheat, oats, those kind of grasses, and legumes. Legumes are in the peas and bean family, and their unique function in the plant world is legumes deposit nitrogen in the soil, and nitrogen is the primary plant food. So by planting the cover crop, you're establishing grasses whose purpose is simply to be chopped down in the spring, ground up, and left in the soil as food for all the soil creatures. So that's why you plant grasses, and why you plant the legumes is to get the nitrogen deposited in the soil. Very, very important practice. Cover cropping. We do a lot with composting. Organic gardeners usually make their own compost. Not difficult. It takes a little bit of effort. Not difficult, and really price effective, because essentially it costs you nothing. You salvage the waste products from gardening and you turn them into the substance that we call compost, which is a really dynamite plant food. Instead of synthetic chemicals, organic gardeners use biological pest controls, and that's a really nice way to work. Gardens have insects and predators that prey on the plants, and every gardener gets hysterical because the bugs are eating my plants. Organic gardeners investigate and find what kind of creatures will eat these bugs that are eating my plants, and you try to use best biological pest control by using those insect predators. And another thing that organic gardeners do is they try to plant different plants, flowers, herbs, which act as companions to their vegetable garden. Companions in the sense that they support and encourage the vegetables to grow very robust and very strong. And companions in the sense that they attract insects that kill the insects that eat your plants. So it's biological pest control. You try to work with nature, and it eliminates the whole synthetic chemical process, which has a myriad of problems. Organic gardeners also use natural substances as plant support things like manure, things like compost, things like a substance called biochar, peat moss, kelp, something from the sea, for example, kelp or eelgrass, and other natural elements, specifically, most of the time, lime or sulfur, which will regulate the pH, the acid content of your soil, so that it is optimal for vegetable plant growth. So those are some of the tools, and we went into detail on them. I'm just bringing your mind back. That's the theory, and that's the practice. That's the way it works. Let me just quickly detail the composting process because it's so important. I said composting uses waste products from vegetable growth, and that's true. In your kitchen, you know that when you feed your family vegetables, the first thing you do is you clean the vegetables you bought from the store, and you remove from the vegetable plant greens from the store any undesirable plants or wilted plants, leaves, and other things. So to make sure you give nice, clean food to your family. Those, what I call plant scraps, that's a part of the compost system. Take those plant scraps, instead of putting them into the garbage pail, which is what we all do, put them into your compost pile. And I'll go into a little bit of detail with you on how to do it. But the plant scraps, other examples of plant scraps. When you weed your garden, the weeds that you take out are plant scraps. They're good to put into the compost pile, because the compost pile will kill the weeds and kill the weed seeds and transform them from plants into compost over a period of time and with some care. Sometimes your plants grow too much. They get too big. They get out of the area that you want to confine them. So you trim them. We trim them. We cut them back, and those cuttings are also suitable to use in your compost pile. In the autumn, a lot of leaves come down from the trees, and that's wonderful stuff to put into the compost pile. Some people use coffee grinds. That works great. You could put that in compost. Eggshells are wonderful to put in compost because they're almost pure calcium. The thing to be careful with eggshells is you have to, I use a spoon and a cup, you have to crush them down as much as you can, small as you can make them, because it takes a long time for the calcium to decompose. And if it goes in as whole eggshells, it'll take a couple of years to decompose. But if you break the eggshells down into powder or little granules, they decompose much more quickly. All of those things go into a compost pile, and the compost pile is managed by periodically, every 2 or 3 weeks, say every 3 weeks, taking a pitchfork and going into the pile of vegetable scraps and trimmings and turning it upside down and turn it. Why do you want to do that? Because the compost process requires air. And the microbes that break down the vegetable scraps and the trimmings are aerobic bacteria, and they need oxygen. So you have to turn the compost pile every few weeks to give those bacteria the oxygen that they need. Some things you don't put in the compost pile, and this is important. Sometimes your plants get diseased and they turn yellow and have brown or black spots on them. Never put diseased plants in the compost pile. They will survive the heat of the composting process, and you'll plant diseased plants next year. So throw the diseased plants in the garbage. Don't plant meat. Don't put meat in the compost pile. Don't put dairy in the compost pile, unless you want to bring animals around. You know, you want to get some skunks, or you want to get some raccoons, or you want to get some rats. That's what you're going to get when you put your meat in your compost pile. Don't put.
Somebody asked, Vince, how much sun does the compost pile need on a daily basis?
So, compost pile will function with very little sun. Sun is not a requirement for the composting process, the way sunshine is a requirement for the vegetable plants to produce fruit. Vegetable plants have to have sunshine, full sun if possible, to produce fruit. Compost does not need sun in order to work. So you can put the compost pile on the perimeter of your garden, for instance, where you might have some trees or something. That's okay. The compost process is still going to work if you put the trimmings and the plant scraps and you turn them every few weeks. You're going to make good compost, sun or not sun. Don't put dog manure, cow manure. Don't put dog manure, cat manure, pig manure, human manure. Don't put that stuff in the compost pile. It's generally speaking, it's a poor practice to put commercially grown flowers in the compost pile because a lot of them are imported from Colombia, but that's not the reason. In order to get them to be as spectacular as they are, when we see them in the flower shops, they get loaded with chemicals. They're protected from every kind of predator or insect or anything that will interfere with their magnificent appearance. And you don't want those chemicals in your compost pile. So my recommendation to you is when your beautiful cut flowers past their stage and are no longer beautiful, throw them in the garbage. That's all. Don't put them in the compost pile. Every few weeks you've got to turn it, and what's going to happen is the pile is going to get larger and larger as time goes by, and you're going to have to move it a little bit from the stuff that's been composting for a month or 2 months. You don't want to mix the new compost in there because that stuff is not ready yet. So you take the older compost and you move it over, and you put your fresh compost ingredients right next to it, and you do the same thing. 4 inches of plant scraps, 2 inches of minerals, manure, compost, brown leaves, and you mix them up every 3 weeks. And then that pile eventually will get big enough where you don't want to add new green material to it. So you take it and you put it on the other pile, and you kind of help the compost to age. And it takes a little bit of time. What's important about compost is this. Compost supports the living critters in the soil in a lot of ways. And the living soil takes carbon out of the atmosphere. It holds water. The compost helps you to encourage life to grow in your soil, and then you get these other ancillary benefits from living soil. To organic gardening, building living soil is the key to success. So the practices I mentioned earlier on, plus the composting process, these are the ways you build living soil. And what's so great about living soil? You've got critters in the living soil, living organisms. You want to feed the living organisms in the soil and let those living organisms feed your plants. And by their lifestyle, you'll see, and we have already seen in the previous videos, the microorganisms in living their life interact with the roots of the plants and bring food to the plant that the plant would not otherwise be able to reach. So the organisms in the soil are alive and are encouraged to be alive by adding organic matter, including compost, peat moss, cow manure, et cetera, to the soil mix. Don't go to the garden center, buy a bag of plant food and feed the plants. That's really poor advice because it does not harmonize with the way plants live, the way plants are structured to live. and they're structured to live by getting nourishment from the roots and by getting sunshine so that they can do photosynthesis. So build the soil, let the soil, so the soil contains living organisms, and let the living organisms in the soil feed your plants. It works dynamite. And most of it doesn't cost that much money. The amendments, the soil amendments cost money, which you'll have to use in the beginning until your soil becomes enriched. And then you'll find you'll need fewer and fewer soil amendments because the organisms living in the soil and the plants growing in the soil will create the soil amendments. The roots of the plants will rot in the soil. The organisms will excrete and sustain the soil. So you might, a very accurate term is do biological agriculture in your garden. Think of the way things grow, what their growing requirements are, and satisfy them biologically as opposed to chemically or some other way. Starting, just some important gardening practices. I want to be specific here. Soil testing. We spoke about soil testing earlier on. You really need to test the soil to find out what its chemical composition is and how that harmonizes with what the plants need. I'll give you an example with the acid content of the soil. Some plants need soil that has a high amount of acid. So I'm thinking flowering shrubs, rhododendron, azalea, pine trees. They like acid in the soil. They like soil to be on the acid side. There are other plants that are exactly the opposite, and they like soil that has more basic properties and less acid. Vegetable plants like soil to be slightly acid. They want some acid, but not a lot of acid. So you can only determine that with a soil test. I know the garden centers sell some kind of soil testing kit to help you check the acid in the soil. I guess some of them have some reliability, but I completely ignore them because I send the soil I send the soil samples to a chemical laboratory where they not only tell me the acidity in the soil, but they tell me all the other chemicals in the soil that plants require. And they let me know if my soil has an abundance of those plant requirements or if my soil is short of those plant requirements. And not only does the chemical soil test give you the information, the chemical soil test from the laboratory will make recommendations to you, what you should do to improve the situation. And it's very specific. As I said, acid, you put lime on the ground, that neutralizes the acid. Too much base, too much alkaline, put sulfur in the soil, it brings it back to where it needs to be. And that's true of all of the chemicals. So the starting point, have a chemical soil analysis. You have to send it to a soil testing laboratory. UNH has a soil testing laboratory. And we went into details how to take a soil test and send it to them. So there's no need to go through that all over again in detail. When you do your planting, my strong recommendation was to include with your seeds and with your plants this black powder, which is actually living mycorrhizal fungi. Those fungi support the root growth of the plants tremendously. And I strongly recommend that you add the mycorrhizal fungi when you dig a hole to slip the plant into, the little seedling. Put some black powder in the bottom of the hole. When you take the seedling out of the growing tray, put some black powder around the root ball. Those are living fungi which will support that plant forever. They're not fertilizer. It's not fertilizer. It's a living, it looks like black powder, but what it is a collection of living creatures. You always, every time you plant, you use those mycorrhizal oils. Watering, we mentioned when you water, best to water early in the morning for the plants, and best to try real hard not to wet the leaves. I know in the morning, most summer mornings, the leaves on the plants are all wet from the evening's dew. So by 9 o'clock, it all evaporates and the leaves are dry for the rest of the day. Try not to wet the leaves of the plants when you water, which you need to do regularly. You might have to do it a couple of times a week if the weather is not too hot and not too dry. But if you get those hot, stifling, dry days in the heat of summer, you're going to have to water that garden every day. The plants will just exude all the water that you put on them through the stomates on the bottom of the leaves. So you've got to pay close attention to the watering. There are a couple of devices I got into detail with. Soaker hose and drip irrigation hose are special hoses which allow water to escape along their length so that water can reach plants which are placed in your garden, oftentimes in rows. So you need to take care of the watering in that way. Try to water in the morning, use a soaker hose or a drip irrigation system to make your life easier, and do it as often as you need it. And they're going to need a lot of water. Test if the plants need water. Just stick your hand into the ground near the base of the plant, way down, cover your whole hand, and feel what it feels like at your fingertips. If it's warm and dry, man, you better put water on those plants. You know, the next day they're going to be all wilted. If it's damp and coolish, well, the water is fine. The plants are okay. So it's a simple way to find out, do my plants need water? If it gets to the point where your plants wilt, you know, they hang like a weeping willow tree, that's really, really bad. Tomorrow they're going to be dead. And it interferes with their growth processes and with their protection against insects and other organisms. Don't ever let that happen. Just be proactive with the watering. Fertilizing, you'll need to fertilize to encourage growth. Use the amendments, spring and fall, and you can add compost. Compost is a great amendment. You can add that all year long. As your plants are growing, you can take some compost and you can put it at the base of the plant as a top dressing. You call it a top dressing. So let the rain and whatever drain through that compost and let that composted water get to the roots of the plants. That's a great practice, and you could and should do that. We spoke about manures. I just want to repeat because this is important. Only use aged manure. Never use fresh manure, green manure. That's the process where manure makes people sick. When you're using green manure and your vegetable touches that green manure, That's how the organisms get transferred. The sickness-causing organisms get transferred from the green manure into your vegetables. Don't ever use green manure. Use composted manure, use dry manure. If you go to a farm to buy it, just ask the farmer, where's the old manure and the aged manure, and he'll tell you, no problem. Important to use. My personal recommendation is never put horse manure in your garden. Not because there's anything wrong with horse manure as manure, but because horse manure tends to be full of weed seeds. And you put horse manure in your garden in the fall, and you're just planting weeds for next year. So I boycott horse manure as a soil amendment, but I use all of the other manures. Remember cover cropping, it's important. Don't leave the soil bare over the winter. Get those grasses and legumes and daikon radishes, even mustard if you've had fungus problems. Sometimes you add mustard plant to the cover crop. Really, really important. I mentioned to you biological gardening. If you just work in harmony with the life processes of the plants, it helps, and it is what organic gardening is all about. Not to bring external chemicals in to do something. Use the plant's lifestyle and the lifestyle of the organisms in your soil to complement each other and to support each other. Another way of doing that is something that's commonly called companion plants. Some plants, believe it or not, some plants are friends. And if you plant them near each other, they help each other to grow better. For instance, tomatoes and basil. The Indians used to use pole beans and squash and corn, pole beans, and squash to complement each other and to help each other to grow better. That's called companion planting. And it's a real good practice to do. And there are companion planting charts. I've got 3 pages of companion planting charts in my book. They help the plants help each other by growing naturally. Also, interestingly enough, there are companion enemies. Some plants just don't do well when they have certain other plants next to them. So research and use the companion plants, plant the herbs where they'll support the vegetable plants, use of flowers also. Flowers also have not only the effect of attracting insects and predators to your garden, but the flowers also support the plants, so the plant growth. So companion planting and anti-companions. Just techniques. You want to be a gardener? These are some gardening techniques. Okay, there have been some recent innovations I'm not going to spend too much time on. Compost tea, we'll talk about in a little bit. Grafting, the tomato plants nowadays are being grafted to get stronger root growth attached to more desirable fruit varieties. Biochar, a new really powerful soil amendment. And the mycorrhizal inoculants that we've already spoken about. I think I'm going to take a break now to show the film. First of all, Susan, do we have any other questions? Okay. This part of the film. It's a little bit longer than the others were, but it is absolutely astonishing. And it'll help you get an appreciation for what you're doing when you're dealing with the plants. And that's why I included in the course. So here it comes, and enjoy it.
Kin recognition is an essential skill.
Animals use kin recognition for two things: to recognize their relatives and avoid mating with them, and to benefit their relatives in social interaction. So animals may give off warning calls if there's a predator near, only if their relatives are near, but not if strangers are around. And animals will generally avoid mating with relatives. It's well known that plants have a mechanism to at least avoid mating with themselves, so it's a kind of kin recognition. But people hadn't known if plants could benefit their relatives in social interactions, and that's what we've been working on.
When she began her research, Dudley knew that plants could sense the presence of other plants above the ground. Using photo or light receptors in their leaves, they can sense when they're being shaded by a neighbor and respond by growing taller or in a different direction to compete for light. And plant roots have a similar ability.
People have shown that plant roots would respond differently to their own roots than to a neighbor's root. So the question is, can they do anything? Do they know who they're interacting with? So I said, well, this is a good place to look for kin recognition, because wouldn't it be cool? So this is the right habitat.
So Dudley and student Amanda File headed for the shores of Lake Ontario on a hunt for a very special kind of plant to see if its roots behave differently when growing next to its kin. It's called sea rocket, and its reproductive behavior made it ideal for a kinship study.
Ah, here's a good-sized plant.
Sea rocket produces two different kinds of seed pods, one of which clings to its mother, resulting in seedlings that often grow up side by side in a family group.
It's in flower, and it's got a few big fruits. This is probably the biggest one. And because they're annual plants, the mother plant dies, can get buried by, by the wind and the waves, and so you have a whole bunch of seedlings potentially coming up from that buried dead mother plant. So they would all be siblings sharing the same mother.
And family members were exactly what Dudley was after. In a series of experiments, she and File planted some sea rocket siblings together and others with unrelated plants. After a few weeks, they cleaned the roots, weighed them, then checked to see if there was a difference between those growing with siblings versus strangers.
I was extremely shocked because we got exactly what we predicted. And this doesn't happen often in science. We're predicting a response. We found exactly that. With siblings, there's lower root allocation than with strangers.
In other words, strangers grew more roots to compete for food, while siblings politely restrained their root growth. So was that evidence of a family sharing resources? Was it proof of altruistic behavior?
Altruism is defined as doing a benefit to others at some cost to yourselves. And it's one of the things get involved by kin selection, but it's not the only one. Two plants that do not compete avoid paying that cost of competition, and because they're benefiting a relative, their genes are passed on to a greater extent.
But whether it's a case of enlightened self-interest or a selfless sharing of resources, no one knew how these plants were identifying their kin. Dudley knew that all plants exude chemicals from their roots, so maybe sea rocket roots were identifying one another via chemical signals. To test that theory, Dudley and her collaborators turned to Arabidopsis, a fast-growing plant that exhibited the same kin response as sea rocket. When they placed two siblings in water and blocked all chemical signals, the seedlings suddenly started ramping up their root growth. Without the ability to chemically communicate, siblings had become strangers.
Is it communication? Are they deliberately sending a signal? That we don't know. That's something that we can't answer yet.
Since then, Dudley's lab has gone on to document sibling responses in at least 3 other species of plants. Now, she and File are moving on to study some of the longest-lived plants on Earth. To answer an even more surprising question, do mother trees nurture their young? It's a question that's been asked before. On the other side of the continent, there's a species of tree that's defying all of our expectations about the social lives of plants. In the feature film Avatar, an ancient mother tree creates a magical network that sustains every living organism in the forest. Here, in the rainforests of British Columbia, scientist Suzanne Simard has been studying the real mother trees and the vast underground networks they create to nurture their own kind.
When I saw the movie Avatar, I was sitting in the audience with my 3D glasses on, and there is the mother tree and the network growing out of the mother tree, and I just went, oh, they read my papers.
Those papers focused on the magnificent Douglas fir, a tree that can live up to 1,000 years and grow to a staggering height of more than 300 feet. But like all trees, only part of its total mass can be seen above the ground.
I feel when I'm walking through the forest that I'm gliding past an iceberg, because what I am seeing is just the tip of what's going on. What we see above ground is just such a small fraction of the body of the ecosystem. In a lot of ecosystems, over 2/3 of what you see is actually below ground. We're seeing 1/3 of the body of the forest.
That mysterious underground world has preoccupied Simard for more than a decade. But while evolutionary theory told a story about competition, the trees themselves were telling her a different story.
We think of them as these individuals that are just competing against each other. You know, I'm going to get this and I'm going to get it and you're not going to get it. And that's really led a lot of the thinking, and we've long ignored, a lot of the other interactions other than competition. But at the same time, there's a community effect that we haven't understood, and we're just starting to really look at this and understand that this is a system. It's not just a bunch of individuals competing against each other. They're working together to make this system work.
So what does that community look like? And how do trees work together? To answer these questions, Simard focused not only on the below-ground world of the Douglas fir, but on their relationship with some of the strangest-looking organisms in the forest.
And these trees are all connected below ground by their roots and also by fungi. And you can often see the fruiting bodies of the fungi right next to old trees like this.
Neither plant nor animal, the fruiting bodies of fungi like this bloom in the spring and fall. Each of their gills is filled with tiny spores, the source of the next generation. And just like the fruiting bodies of trees, mushrooms represent only a tiny fraction of a vast organism that lives below the ground, in networks made up of roots and organic material, like this bright yellow fungal tissue.
If we could see in that soil, we'd realize there's layer after layer of just networks and these are big organisms. Just like these trees are really, really big, so too are the mushrooms. They're just flat and they happen to be predominantly in the soil.
When you're walking on the forest floor, you're walking on this massive amount of fungus material. And so anything that grows or germinates in the forest floor can't help but be colonized.
In fact, the massive underground roots of fir trees are colonized by below-ground fungi because the fungi can't produce their own food. Instead, their vast underground networks tap into the roots of trees and other plants. The plants provide the fungi with carbon-based sugar, and the fungal network returns the favor, providing the trees with nutrients. Many plant species are dependent on fungi for their survival, and the Douglas fir is no exception. In turn, the underground fungi are equally dependent on the tree's carbon.
It absolutely needs that carbon. It cannot live without the carbon from the tree. There's a signaling that goes on between the root and the fungus, and they say, hey, we can help each other out. And the reason the trees associate and do this for the fungi is that the fungi are so small, right? They can crawl into little soil spaces that roots can't grow. It costs a lot less in carbon to support the fungi than to build its own root system. And so it's a great trading system. It shuttles a lot of carbon to the fungi. The fungi then shuttle it between themselves from fungus to fungus, but also fungi can also connect the trees together.
Simard has demonstrated that vast underground fungal networks link the Douglas firs together into a kind of resource-sharing community.
We found that the big old Douglas fir are hubs for this massive network that is connecting pretty much all the trees in the forest. And the bigger the tree and the older the tree, the more roots that it's growing and the more mycorrhizal connections that it has. And what we found is that those connections are providing really a rearing ground for the new trees that are coming up.
And experiments like this one demonstrate how that network operates. First, Simard and graduate student Marcus Bingham bag the branches of an older mother tree, then expose it to radioactive carbon-14, a gas the tree naturally absorbs to produce its food.
Okay, so let's just inject this C14 or radioactive gas, CO2 gas, and within a few hours it's going to be coming down the trunk in its sugars and into the root system, and then in a day or two we should see the radioactivity.
Days later, the team returns to track where the radioactive carbon has gone using a Geiger counter. The results are nothing short of amazing.
Yeah, let's pull out the Geiger counter, see what we've got.
Oh yeah.
Not only has the underground network shuttled the mother tree's carbon-based food to surrounding trees, experiments like this one reveal that the biggest beneficiaries are the youngest, most vulnerable trees.
It's right in the foliage. So that parent tree is really giving lots of carbon to its offspring here.
This seedling over here and see if that's picked up.
Sure. Okay. Oh yeah, this is all hot down here. It's great. The whole network's lit up. Yeah. Yeah. That provides this great source of nourishment for those little seedlings. In an old forest, you can imagine that there's not a lot of light. It's quite shaded. They don't have the ability to fix their own carbon very well. They're really being nurtured and grown up as a community, as a family almost. And it's those relationships that really build the forest. It's really a beautiful, self-organizing, complex system. What we're finding is amazing, and I know that there are naysayers out there, but those of us who are seeing this are just going, wow, it's awesome.
So if mother trees can nurture their own kind, if plants can recognize family members and communicate with their friends and foes, how are they doing it if they have no brain? No way to organize or integrate the information they receive.
It's an interesting question, both philosophically but also biologically. How do you integrate information if you don't have a nervous system? Plants may have a parallel system. There has to be something that's doing this integration. We just don't know what to look for.
Maybe we're not quite as smart as we thought we were, and perhaps plants are a lot more intelligent than we ever imagined.
Bravo. Bravo. I hope you folks found that worthwhile, these videos that I've been sharing with you. I'm trying to get you to appreciate the fact that plants are fantastic creatures, and as a plantsman or a planter or a gardener, the wise approach is to harmonize your efforts and your techniques with the nature of the plant. So you kind of believe they do okay on their own, but you can give them some support. You can help them by understanding their lifestyle and their life requirements, and give them what they need. And particularly in a garden situation where the objective is the fruit or the food. The objective is to use the plants for food. So it's not that you're raising beautiful flowers or beautiful shrubs. You're raising food you want to eat. So try to get an understanding of what the plants need by learning about their growing habits, and then give them what they need and enjoy the benefit of a large harvest. I hope you enjoyed it. I'm fascinated every time I see it, and I see it frequently, but I still find it fascinating. I want to talk a little bit about the process of organic certification. You see the expression certified organic on produce, and what does it mean? Well, what it means is this. Years ago, I guess 20 years ago or so, I don't know exactly the date, a bunch of people who wanted to grow vegetables organically got together and formed an organization of organic growers. And they had some influence with the government, where they got some kind of specific status, organic vegetables, and it obtained a government definition of what it means to be organic. And in the world of commerce, the rule was made that you cannot call your produce organic unless it complies with the organic standards. And a group was set up to devise more or less the rules of organic growing. And if you conform to the rules, you could call your produce certified organic, except it's not quite that easy, naturally. Certified, what has this certified got to do with it? A mechanism was established where farms that wanted to be known as organic and certified organic had to go through an inspection process. And I'll give you some details. In 1990, the federal government passed this legislation that defines and regulates and establishes an organic food growing organization. And one part of growing food organically, and they set up a whole rule book, all different things you have to do to be organic, called organic. One part of it is your farm, your growing operation must be inspected. And the requirement is an annual inspection, and you get inspected by an experienced, knowledgeable organic grower. A person who knows about organic agriculture and knows about organic growing techniques and organic principles, and that person comes and checks on what you are doing and how are you doing it in your garden. That process, that inspection, first of all, the inspection process takes about usually takes about a half a day to get inspected. Secondly, it costs $1,000 to get inspected. And the organic farmer pays the $1,000 to the inspector, actually to the inspector's organization, not to the inspector individual, to the inspection organization. However, the federal government reimburses the farmer for $750. So the annual inspection that takes about a half a day under the watchful eye of an expert organic grower costs the farmer out of pocket about $250 to get that, to be called certified, to get that stamp of approval and a certificate that says this farm has been certified in compliance with all organic procedures and requirements. That certification has a life of 1 year. A year later, you have to have your garden recertified, re-inspected and recertified. So the farmer goes through the process again. And the inspector is not connected in any way with the farm that he's inspecting. The inspector works for a certifying organization, which is independent, an independent certifying body. And that's who pays him. Not only, and what he looks for is your practices, your purchases, what kind of materials are you bringing onto your farm, your record keeping, you know, how good are you at recording your organization, your operation. So that's what a certified organic, and that's the thing you'll see. One of the requirements, interestingly enough, for becoming a certified organic farmer is you have to have been growing according to organic principles for 3 years before they will give you a certificate. So first year the inspector comes and you don't get a certificate. The second year you don't get a certificate. The third year you got to establish that you've been growing for 3 years, and then you pass the inspection requirements and you get a certificate. That's because pre-organic growing, a lot of soil and a lot of plants were contaminated with chemicals. And those chemicals oftentimes had harmful effects on other critters and on people. So the 3-year period was a clean out period. Get rid of all the poisons, get rid of all the undesirable stuff that's in the soil, and come to the inspector with clean ground, and then you get your thing, your certificate. It's a very effective system. It started out as being a totally honorable system, but it has become somewhat corrupted because the board, the governing board that does the certifying, it's composed of, I think, 9 members who make and establish the rules and oversee the actual field inspections. They started out being all organic farmers, dedicated organic farmers. You might say fanatical organic farmers. However, since organic produce in the stores was bringing a premium price over conventionally grown vegetables, some conventionally growers wanted to be able to raise their prices to the organic level, but they were unable to do it until they qualified to meet the organic standards. And the 9 members of the board, you began to get applications to join the board from people who worked for chemical companies. Monsanto and Dow Chemical and other chemical companies were making an effort to place their employees as rule makers in the organic standards board. And that did go on, and that has led to a modification in the requirements for organic certification. And that modification is not an improvement in the requirements for organic certification, but it is a compromise. It is a watering down of requirements for organic certification. So what you have now is the corruption of the organic inspection process by non-organic growers as their business attempt to be able to call their operation organic and get it certified as organic, and then raise their prices to the organic price level. The regulatory bodies like the Food and Drug Administration and the National Organic Standards Boards, so those were beginning to have members who are not organic farmers and who did not have the dedication to pure organics that the others, the traditional members had. They had a side agenda. And that has affected what goes on in the marketplace now. The traditionalists, the old, reliable, dedicated organic people are panicked at what they consider their operation being spoiled or being compromised. And they're trying to work on some other way of identifying traditionally produced organic produce produced according to the original very stern organic standards. You see things like real organic, regenerative organic agriculture. There's a movement trying to neutralize the compromise that the industrial agriculturalists, the chemical companies made with organic growing. So that's a constant unfortunately spoiled the purpose of original organic certification, but people are dealing with it. If you'll allow me, I just want to talk a little bit about these people that we call organic farmers. I've had a lot of contact with them as an organic grower myself, so we're colleagues. As an observer, I go to the organic farming conventions and I see hundreds of organic people and growers, and we chit-chat and talk back and forth about our way of life. And I began to be very puzzled. At a couple of these conventions, I saw young people, men and women, youngish, and they're there learning about organic agriculture and having intentions of working on organic farms to learn how to do organics. And I had a conversation with them sometimes. And I said, what are you doing here? This is a meeting of people who grow organic food. These are farmers. You've got a college degree. You didn't study agriculture when you were in college. Why are you here with a bunch of organic farmers trying with the intention of learning how to be an organic vegetable grower? And you know what they said to me? Really astonishing. I want to live my life in a way which is constructive and wholesome and helpful to people. I want to have respect for myself, for my work, and I want to do what I consider to be good, ethical, honorable work, and that's the lifestyle I want to live. And that's why I'm here, because I want to try to do that by being an organic farmer. Oh my God, really knocked my socks off. And I was really, really impressed and delighted, actually, but I didn't know that there was some young people whose brains were working this way. And then I met another guy, a guy who was one of the officers of the New York State Organic Farming Association. And I got to know him personally, and he was a young guy and his wife, and they had a farm. It ends up that this guy's father owns a hardware store, a very successful, large hardware store. And I mean, it's his son. The kid just walks in the door. He's got it. I mean, the old man made all the trials and tribulations and took all the chances to get it established. Now it's established and running and profitable, and all the kid's got to do is walk in the door and he takes it over. So I didn't exactly say to him, hey, are you nuts or something? I didn't say that. I just said, well, why? You know, why have you made this decision? And I don't want to live my life selling all that crap to people. And that was his reasoning. Between the paints and other stuff, I guess, chemicals of one nature or another, turpentine, he considered that an undesirable way of life, and he walked away from the economic opportunity to be true to his standards, his life standards. And I think that's something that you will find among this group of people who do organic agriculture. I'm encouraging you. I'm really encouraging you. If you have an interest in growing vegetables in your backyard, the organic way, that's wonderful. God bless you. Do it, enjoy it, get the benefits from it. But if you would rather buy your vegetables somewhere, somehow, turn your back on the supermarket and talk to the organic growers. There are all different kinds of ways of paying for the organic vegetables. They have annual things. They have some systems of payment. But what you're going to find are decent, honorable human beings who are trying to do the right thing and make enough money to survive at it. And they're not interested in maximizing income. And they're not interested in all the goodies that our society has to offer. They're interested in a lifestyle. I want to do some kind of work that I can be proud of and be proud of myself and feel like I have some dignity. And if that psychology has any meaning to you or any value to you, to my viewers, spend a little time with them. Go to their farm, talk with them, find out what they do and why they do it, and you will find not a viciously commercial or economic attitude. You go to a lot of businesses, all they want is your money. Here's the product, give me the money. You know, here's the service, pay me, and on to the next guy. That's not the way their minds work. That's not where they're coming from. And you might find that you enjoy doing business that way, and you enjoy doing business with people who think that way and who feel that way. It'll be different than your ordinary commercial contacts. So I would encourage you, just like I did, I sought them out. I even became one of them. Seek them out, get to know them, talk to them. Find out if there's anything you have in common or any way you want to involve these kind of people in your life as opposed to the sharp businessman who only counts the bucks. So that's I'm sharing my experience with you. Their highest priority to live a satisfying, wholesome lifestyle. That's what these guys are all about, almost universally. And by the way, that's not to say they're economically deprived. Some of them make a lot of money. Farming could be a good business if you run it, you know, efficiently. You can make money as an organic farmer, and a lot of them do. A lot of them also struggle. I mean, this is another ridiculous thing. I met a person, a woman actually, only. Her and her husband were both college professors. For some reason, I don't know the whole story or whatever the story is, they decided they wanted to try organic farming. They left their teaching jobs, they bought a farm, and they lived for 2 years in a tent. Because they were pursuing their dream or their goal or their objective. And it's just astonishing. I don't know, human beings are marvelous creatures, just like plants are. But that's a true story. I know those people personally, and she's grown to be one of the leaders in the organic field. She's noted everywhere, always speaking, always lecturing, always writing, always being quoted. So I'm sharing an aspect of organic agriculture with you. It's not how to do the planting. I already did a lot of that. I taught you how to do the planting. Now I'm trying to acquaint you with that, trying to get you to understand that there's more to this organic stuff than just buying the vegetables. It represents a lifestyle to people, and the people who are involved in it are not sharpie business guys who are always out for the money. And if you like to deal with people of that character, that might be a good reason to build some organic food into your shopping. Okay, so that's what I have to say about that. I want to move on. Right now we have this agricultural system which is unnatural in the sense that they grow only one crop over large acreages, which is unnatural. You never see that in nature. Nature only grows one plant. In nature, all plants are always mixed up together. But they grow one plant for efficiency's sake. And because they grow one plant only, God forbid a bug comes along who loves that plant, he's going to have acres and acres of food. So he'll go call his mother and his grandmother and his sister and his aunt and his uncle and his kids, and they'll all go charging to this food source, this never-ending food source, and you'll have the farmer losing his crop to the insects. So the farmer, of course, to protect his investment and to earn a living, he's got to defend his work. So he does it by buying pesticides, kill these bugs, and leave my plant alone. And that's what goes on. And there might be some alternatives. Now we have obviously the organized organic alternative. How about doing something in your own backyard? How about growing some of your own vegetables? You're listening to this guy spiel and trying to learn something about organic growing. It's legitimate. It's what you're going to find if you're not familiar with it. What you're going to find is hard work, tremendous enjoyment and satisfaction, nutritious food, better than the stuff they sell in the stores, nutritious food, and pleasant life experience. It's nice to be out in the weather. I mean, not when it's 100 degrees, that's not so nice, but it's nice to be outside in the air and nurturing the plants and getting the joy and satisfaction of seeing these little tiny things that you put in the ground, and they come and they grow and they get larger and they get more beautiful, and then they serve a practical purpose because you bring them to the market and you sell them, or you put them into your house and your family gets good nourishment. So that's an alternative to just going to the supermarket and buying everything off the shelf. And we, I don't have a garden now. So I find myself in the supermarket buying vegetables. I always try to pick the organic varieties, but I'm not as hands-on as I used to be. And I didn't start out to be an organic farmer. I started out just to grow some clean vegetables, and then I guess I got bitten by the bug and went crazy. But just do yourself, do your family a favor, and find a way to give them wholesome, nutritious food, clean food. They'll all be better off for it. So that's one alternative to the current industrial agriculture system. Grow your own. Just let me tell you this. I taught a class. At the end of the class, this youngish woman comes up to me and says, "Thank you for the class. I learned a lot. I want to learn how to grow vegetables to feed to my baby. I have a newborn baby and I don't want to feed her the stuff they sell in the stores." I almost collapsed. I couldn't even imagine someone thinking like that. And there was this woman, in all sincerity, she wants to be a responsible mother, and she doesn't have confidence in the stores or what they sell, so she's going to do it herself. Not all of us can make that happen, but maybe you can do some of it. I want to make some suggestions about farming systems. Right now, we've got this enormous farming system all over the country, gigantic farms, and unbelievably productive machinery and process. But maybe we can find ways to grow vegetables on a smaller scale, where we don't need these tremendously expensive big machinery for such tremendous volume of production. Maybe we can start to do things on a smaller yet effective scale. For instance, a guy, this is theoretical, a guy buys 100 acres of land from some farmers, and he's going to put up a housing development. I'm going to put 100 houses on these acres, or 200 houses on these acres. Okay, fine. God bless you. Good luck to you. Have a nice life. Why can't there be some kind of a requirement that says, if you're going to put up 100 houses, you have to have a farm that grows vegetables enough to feed these 100 families? I mean, what's wrong with that? Why can't we require farms, organic farms, of course, in specific locales? And there's a professor working at Columbia University. When I first heard about it, I thought he was a nut. His idea is, let's grow vegetables in apartment buildings. Let's take a floor of an apartment building and turn it into a farm. And the people who live in the building can buy the vegetables that they grow right in their building. And the technology has come to exist where that's totally possible. These hydroponic gardens that grow without soil, they grow in chemically treated water under special lights, which give the plant the exact light formula that the plant needs. And they're successful, and their produce is in markets right now. So why can't we do that in apartment houses? Why do we build houses? Excuse me for 1 minute, please. My wife says my throat dries up when I talk too much, and she's not wrong. But I have something to say here, and I want to share it with you. Hopefully you'll get some benefit from it. Why do we build houses now? I'm talking about single-family houses or small houses that have a roof shaped like this. Why do we have a peaked roof on most of our houses? I've been wondering about that. I mean, the guy who thought of making those A-frame houses in the snow country where the whole thing is A, shade, to get the snow not to accumulate on top of it, just to drop off. I thought that guy was a genius. But why can't we build houses that have a flat roof? There are structures that we build now that have flat roofs. Almost all commercial buildings have flat roofs. So it can be done. It can be done effectively. Why can't it be done on a single family house? What do we have to do this for? Why can't we make a flat roof? Now you have a place that you could grow a garden. Full sun. A lot of advantages. If you design it properly, you could go there in your bikini and sunbathe. Why not? The flat roof gives practical space, practical usable space. The pointed roof, I don't quite know what it does, but it's something to think about. There are alternatives to our current system. Apartment house farms, backyard gardening, community farms, flat roof houses. All techniques of changes in the society. The way we do things. We don't have to just keep doing what we do in the same way we do all the time just because that's the way it's done. There are alternatives. So with that, let's spend some time answering questions. If people have questions, please feel free to ask. I'm very anxious to respond. Do we have questions? People are not asking questions. I wonder if they're even listening. I wonder if there's anybody out there. Am I talking to myself? Well, it's time for questions. I mean, I've gone through the whole gamut of organic agriculture, organic growing, techniques. I could go through a review.
Oh, here we go. What are your flower recommendations for companion planting?
Okay, I don't have them on the top of my head. I have charts that answer that question, and that information is readily available. It's in my book, and it's in a lot of other places. So I'm sorry I can't give you a definitive answer because I don't know at this moment specific flowers that are other than sunflowers. Sunflowers are very attractive to a lot of insects. Attractive to beneficial insects which will kill the bugs that eat our plants. Sorry, that's the best I could do. It's common knowledge, it's available, but it's not in the back of my head for all of these specific vegetables. I'm sorry.
Someone else asked, how do you manage compost during the winter season?
Pretty much goes dormant. You can't turn it because it freezes. It gets like a big rock. So you more or less are out of the compost activity over the freezing cold winter months. You can plan around it. You can get your compost to be ripe, ready to go into the ground in time to put it on your ground in the autumn after you clean your old dying vegetables away, September, October, November, the end of the season. Then you can take the compost that you have allowed to mature over the year, spread it on the ground as one of your autumn soil amendments, and just leave it there. Just put your cover crop seed right into it. The cover crop will grow, will mature, and then in the springtime you cut down the cover crop and you rototill everything in, including the compost that you put in your garden last autumn. So you certainly could do that, and I recommend that. But you won't be able to work the compost, or you won't be able to make compost in the winter.
How important is it to
Unless you have some way to control the temperature. If you have a building that you could reasonably near your garden, and you have an ability to prevent soil from freezing in that building, then I guess you could continue to compost. But I don't know that, practically speaking, most homeowners have that. Go ahead.
How important is it to prune vegetable plants?
It's probably very important to prune vegetable plants, and there are a couple of reasons for that. One, and the most obvious one, is sometimes the plants grow larger than you want them to be, and they start intruding in places where you wish there were no plants. So you just prune them. You just cut off the overgrowth and put it in your compost pile, and you control your growth. You control your plant's growth by that technique. You also prune plants. Some plants, well, this applies mostly to trees, but some plants also, you want to increase the amount of fruit that you get from the plant. And one way of accomplishing that is if you can bring more sun into the plant. So there might be excess leaves that you would remove in order to generate, in order to allow more sun to generate additional flowers and fruit. What else would you prune plants for? Sometimes you prune plants when they're diseased. You could have leaves on plants diseased, and it's really important to prune those off, because the natural tendency is for disease on plant leaves to spread. And the disease organisms, they're called spores, they're on the leaf, and they are moved around by the wind and by the rain, and they go from the leaf that they're existing on to nearby leaves, and that way spread the disease around the plant or the garden. So in order to prevent that, you try to remove the diseased parts as frequently as you can and as completely as you can, even to the point, if it gets really a dense infestation, just rip the plant out and throw it away. Get the whole thing out of your garden. Rogue it out. But hopefully you won't let things get to that severe extent. You should be able to prune off small diseased parts as they get diseased. So that would be another reason for pruning plants, to control disease. You have to be careful. Those spores are tricky little guys, because they get on your hands, or they get on your gloves, or they get on your tools, and you end up spreading them unintentionally. So you have to be a little bit careful with disease spores.